We're surrounded by some pretty incredible AI. I mean, you snap a photo and your phone just knows it's your cat. But here's the catch. If you ask that same AI why it's a cat, well, it's got nothing. It's a master of pattern recognition, but it doesn't actually understand. And that gap, right there, that's one of the biggest puzzles in artificial intelligence today.
So that's the big question we're going to dive into. How do we build an AI that can finally leap across that canyon from just matching patterns to genuine, honest-to-goodness reasoning and understanding?
All right, to get there, we first have to really get our heads around the fundamental blind spot in most of the AI we interact with every single day. The best way to think about it is like this. Today's AI is that student who crams for a test and memorizes every single answer, but has zero clue what any of it actually means. It's seen millions of cat photos, sure, so it knows the correlation. Fur, whiskers, pointy ears, check, check, check. But it doesn't get the concept of a cat. Show it a weird cartoon drawing of a cat, and it might just throw its hands up in confusion. It's missing that common sense reasoning.
You see, for the longest time, there have been two totally different ways of trying to build intelligent machines. And frankly, both of them have had some pretty serious flaws.
So on one side, you've got Symbolic AI. Think of this as the botanist, a system that follows a super rigid checklist. If it has leaves and a stem, it follows the rule and shouts plant. But show it a cactus, and the whole system just grinds to a halt. No leaves, doesn't fit the rules. On the other side, you have neural networks, the pattern matcher. These things are amazing learners, trained on tons of examples. But show on a really convincing plastic plant, it'll confidently tell you it's a plant. Why? Because it only knows what a plant looks like, not what one actually is. So we've had logic without any real-world intuition, and we've had intuition without any solid logic. So what if we could finally combine the best of both?
And that is exactly what NeuroSymbolic AI is all about. The name really tells you everything you need to know. Neuro is for the neural networks, the part that's so good at learning from massive amounts of data. And symbolic is for that old-school classical AI that's great at step-by-step logical reasoning. You put them together, and you get a system that can finally both see and think.
Let's make this real. Think about a stop sign. When a neurosymbolic system sees one, the neuro part, the pattern matcher, does its job. It sees a red, 8-sided shape. Then the symbolic part kicks in. The logic engine applies a hard rule. If a thing is red and octagonal, then it is a stop sign. This is why it's so robust. It still gets it right even if there's a sticker on the sign or if the lighting is terrible. And that is the huge difference between just recognizing something and truly understanding it.
Okay, but hang on, because this is where things get really, really cool. These systems don't just follow rules that we give them. They can actually learn to create and even update their own.
Imagine we give the AI a really simple starting rule. All mammals have fur. For a lot of cases, dogs, cats, bears, that works just fine.
And then we throw it a curveball, a whale. We know it's a mammal, but it definitely doesn't have fur. Now, a more traditional AI model would just crash and burn here. It's a complete contradiction. But a narrow symbolic system can actually reason its way through the problem. It looks at other facts it knows, like, hey, whales have lungs, and they give birth to live young. And it concludes that, yep, they must still be mammals. So it actually updates its own logic. It learns a more nuanced rule. This is called meta-learning. It's not just learning facts, it is literally learning how to reason.
So this is way more than just some fascinating idea stuck in a research lab. It's already out in the real world, and it's making a serious difference.
In science, it's helping discover new medicines by reasoning about how different molecules might interact. In the world of finance, it's spotting complex fraud patterns that a simple pattern matcher would totally miss. For lawyers, it can analyze incredibly complicated contracts and actually understand the logic inside them. And maybe most importantly, because it can explain itself, it helps us debug and trust our own AI models, finally opening up that black box.
And that ability to explain its thinking step by step, that is an absolute game changer. When we can follow an AI's logic, we can audit it, we can trust it, we can build systems that are more ethical and accountable. So, what does this all mean for us? For the humans in the equation? Well, this isn't a story about machines taking over. It's really a story about a powerful new kind of partnership. The whole goal here isn't to make people obsolete. Not at all. It's to create systems that can work with us, augmenting our own intelligence. They handle the heavy lifting of complex data and logic so that we can focus on the things that we do best.
Because let's be honest, at the end of the day, there are things that are uniquely human. Our creativity, our gut feelings, our ethical judgment, our empathy. No algorithm is ever going to replicate that. This new AI is a tool to make our decisions better,
not to make them for us.
This new team-up between our own intuition and machine logic is just incredibly powerful. And it leaves us with a really fascinating question to think about. As AI finally learns how to reason, how will we learn how to work with it?